Good morning. This is Dr. S. Vasantakumar, lecturer in mathematics, Government Degree College, Puttur, Tirupati. Today I am discussing about inverse Laplace transforms of integrals. It belongs to the inverse Laplace transform. This entire topic belongs to the final year students semester 5. Paper is called 7B. Okay, we know the about the inverse Laplace transforms of integrals. First of all, we know the definition or theorem of the inverse Laplace transforms of integrals. Here, see here, theorem, if L inverse f of p equal to f of t, then L inverse integral p to infinity f of p into dp is equal to f of t by t. Here, by formula is like this. By the formula of Laplace transforms of division by t property of Laplace transforms. This is the formula of division by t property. Okay, Laplace f of t by t is equal to integral p to infinity f of p into dp. So by using this formula, we solve the inverse Laplace transforms of integral property. Applying inverse Laplace transforms on both sides for this formula, here we see L inverse and inverse we apply. Then here L inverse and L will be cancelled. F of t by t is there. Here see here f of t by t. In the left hand side part, L inverse integral p to infinity f of p into dp is equal to f of t by t. This is the formula of the inverse Laplace transforms of integrals. We know the detail in the next slide. Um, the above inverse Laplace transforms of integral formula can be written as like this. Here you see L inverse of integral p to infinity f of p into dp is equal to 1 by t into f of t. F of t is the in terms of L inverse f of p. Okay. Here this t comes left side, therefore L inverse f of p is equal to t into L inverse of p to infinity f of p into dp. In the same way, in the note 2, we described in the replace p by s. The same formula here, replace p by s. These two formulas will be defined as inverse Laplace transforms of integrals. Now we are going to explain one problem. One important example here. Evaluate L inverse integral p to infinity f of 1 by p minus 1 by p minus 1 into dp. Okay, now we are going to solve this problem here. By inverse Laplace transforms of integral formula, we have, see, already we derived this formula. L inverse integral p to infinity f of p into dp is equal to 1 by t into L inverse f of p. Okay, here in the place of f of p, here given in the problem 1 by p minus 1 by p minus 1. We write it 1, that is equal to 1 by t into L inverse f of p means same, it's 1 by p minus 1 by p minus 1. Now we divide 1 by 1, 1 by t into L inverse 1 by p minus L inverse 1 by p minus 1. Okay, now we have formula here, 1 by t into L inverse 1 by p means 1 minus L inverse of 1 by p minus 1 is equal to e power t. Therefore, the final solution is L inverse of integral p to infinity 1 by p minus 1 by p minus 1 into dp is equal to 1 by t into 1 minus e power t. Okay, this is the simple formula. Okay, this is the simple formula. Next, now we are going to explain a little more example here. Example 2, that evaluate L inverse integral p to infinity log of p plus 2 by p plus 1. Here we solve this problem in some little bit different way. See here, let f of p, here f of p is given a log of p plus 2 by p plus 1. We write as this one log p plus 2 minus log p plus 1, because of we know the formula log m by n is equal to log m minus log n. Okay, uh, we differentiate this one on both sides. F of p means f dash p log p plus 2 by 1 by p plus 2, log p plus 1 by is 1 by p plus 1. Okay, you differentiate, then we apply inverse Laplace transforms on both sides here. L inverse f dash p is equal to L inverse 1 by p plus 1 minus 1 by p plus 2. We divide 1 by 1 here. L inverse 1 by P plus 2 minus L inverse 1 by P plus 1. We know the formulas of inverse Laplace transforms. L inverse of 1 by P plus 2 is equal to e power minus 2t, and also here e power minus t. Therefore, here first we find L inverse f dash p. Okay. Next, by inverse Laplace of derivations formulas, okay, L inverse f of p is equal to minus 1 by t into L inverse f dash p. Okay, here we introduce one formula, inverse Laplace transforms of derivations. Here derivations formula, here we submit f of p is equal to log of p plus 2 by p plus 1, that is equal to minus 1 by t into, already we solve this one, L inverse f dash p is equal to e power minus 2t minus e power minus t. Okay, therefore we take it common as minus, therefore 1 by t into e power minus t minus e power minus 2t. This is the solution of L inverse of log of p plus 2 by p plus 1 is equal to 1 by t e power minus t minus e power minus 2t. That's called, we say it's f of t. Okay, this shows in the pink color, f of t. Now applying inverse Laplace transforms of integral formula here. Okay, just we find here just inverse Laplace transform. Now we find Laplace transforms of integral formula. Already we know the formula, we derive in the first slide. L inverse integral p to infinity f of p into dp is equal to f of t by t. Okay, L inverse integral p to infinity f of p dp is equal to, here 1 by t is write down here, in the place f of t he shows here pink color. Okay, f of t is equal to 1 by t e power minus t minus e power minus 2t. Okay, 1 by t into 1 by t is equal to 1 by t square. You replace f of b by log of p plus 2 by p plus 1. Therefore, the final solution is L inverse integral p to infinity log of p plus 2 by p plus 1 is equal to e power minus t minus e power minus 2t by t square. This is the another way of the solving the problem. Okay, in this way we solve the so many problems, different type of problems, inverse Laplace transforms of integrals. Now when we are going to explain some small problem, that is called example 3, evaluate L inverse of 1 by p plus 1 whole square. Here one of the simplest form, let f of p equal to 1 by p plus 1 whole square. We are directly taking here f of p. From inverse Laplace transforms of integral formula, we have L inverse f of p is equal to t into L inverse of integral p to infinity f of p into dp. Okay, here we are taking the problem as f of p, therefore we submitting here f of p. T into L inverse of p to infinity 1 by p plus 1 whole square into dp. Here this one we solve by integral formula. Integral 1 by p plus 1 whole square means minus 1 by p plus 1. Okay, from limits p to infinity. Here we applying limit infinity. Here first one is 0 minus. Again we apply in the place of p, we replace p by 1 by p plus 1. By minus to minus plus is there, t into L inverse of 1 by p plus 1. We know the formula, L inverse of 1 by p plus 1 is equal to t into e power minus t. L inverse of 1 by p plus 1 whole square is equal to t into e power minus t. Okay, in this way we solve so many problems on inverse Laplace transforms of integral. This integral formula will be more useful for final year students, degree final year students, very important. Now I am providing here, you know, one teaching material also. I am providing teaching material. Here I am providing some teaching material. Okay, inverse Laplace transforms of integrals, here teaching material, uh, some reading materials, same problems are there in a method format. Okay, understand, very well for this one. Inverse, these are the references of Fourier series and integral transforms, Fourier transforms. You observe this one, and also I am providing, some PPTs also, PPTs, and also some notes on inverse Laplace transform in PDF format. In PDF form, okay, it is also available in the links are available in the YouTube. Okay, you are going to see some important topics on useful formulas on inverse Laplace transforms of integrals. Okay, these are the very useful for you. And also I am giving some self-assessment questions. A self-assessment questions, in the self-assessment we are giving some true or false questions. Okay, for example, see here, um, is this one true or false, is this one true or false. For example, inverse of 1 by p power n is equal to t power n minus 1 by n minus 1 factorial. Whether it is true or false means it's true. And also some, I'm giving some multiple choice questions also is there. Okay, for example, I take number fourth one, formula of L inverse of 1 by p plus 2, e power 2t, e power t by 2, e power minus t, e power 2t. Which is correct? E power minus 2t is the correct. Therefore, D is the answer. Like that, we are giving some multiple choice questions, and also I am giving match the following also. Here you see here, L inverse of 1 by p plus 2. Okay, which answer is correct? E power minus 2t is the correct. Therefore, this one mapping to D. Okay, answer is 3. D is 3. So in this way, we are forming so many questions, and also it will be useful to you, useful to you. Therefore, um, very useful to you. And also I make good information, another good information I upload in the YouTube also, so that you study well for the exams. Okay, this is the my email ID, Dr. S Vasant mass at the rate of gmail.com. Okay, you are any queries, kindly mail me, I will clarify you. Thank you very much.